Hi, Honors Trig Pre-Calc. We're going to go through section P.1 and P.2, the prerequisite chapter. I'm going to preface this by saying, for some reason, my Smart Notebook document isn't being super responsive, so I'm going to try my best here, but it might look a little choppy, and hopefully in the future they'll be a little bit better. So the first thing is the number line and trichotomy property, which says, if A and B are real numbers. So the symbol for real numbers is that fancy little r. Then there are three things that can happen. Either A is equal to B, A is greater than B, or A is less than B. Now this might seem very simple, but like it kind of is a pretty big deal. That's basically saying for any two numbers, they're either the same number or they're different, and one is greater than the other. This helps us then draw a number line, which you guys know what looks like, where here's 0, let's say this is A, and let's say B is over here. So one of the big things we're going to be using this year is interval notation and inequality notation. So I'm going to start with interval notation, and it's going to look something like this. Let's say from 0 to 10. That means I'm including all the numbers, between and equal to 0 and 10. So here's our interval notation from A to B, from 0 to 10. Inequality notation from 0 to 10, x is between. And how would I graph this? Well, that's going to be all the numbers between 0 and 10, and we are closing the circle, because it can be equal to, and going all the way to 10, where we are also closed. If I change these to parentheses, 0 to 10, that's meaning I am not actually including those, so that would look like this. Oops, I did not mean to do that. 0 is less than x, which is less than 10, so we're not actually including 0 or 10, and we denote that on a graph by using an open circle. So we're going to look something like that. Then, of course, you can either have the equal on the left and not the right, or on the right and not the left. And I'm actually not going to go through those because realistically, it's very similar to what we just did. And then last but not least, what about unbounded intervals? So if I'm looking at something, for example, from 7 to infinity. Couple notes here. The first is that this needs to be a parentheses because I can never actually be infinity. So that's going to be x is greater than or equal to 7, and we would denote that on our number line from 7. We are closing this because I have a bracket, and forever and always in the right direction. Second thing in this section is properties of exponents. I'm going to kind of zip through these. So if I have a to the m times a to the n, I get a to the m plus n. If I have a to the mth power over a to the nth power, I'm really a to the m minus n. If I have anything to the 0 power, that's equal to 1. If I have a to the negative nth power, that's really 1 over a to the n. If I have a times b to the mth power, that's going to be a to the m times b to the m. If I have a to the mth power all raised to the nth power, I realize those are very similar letters, but bear with me. We have a to the m times n. And last but not least, if I have a divided by b to the nth power, it's really a to the nth divided by b to the nth. Next, we have absolute value. So absolute value tells us something's distance from 0. That's its definition. So we know the absolute value of, let's say, 3 is 3, and the absolute value of -3 is also 3, right? We sometimes think about it as making the thing positive, but really it's telling us how far away that thing is from 0. One really important thing, and we're going to look at an example with this in class, but if I have the absolute value, if I have the absolute value of some value a, that means one of three things. That means either it's going to look like that same number if a is greater than 0. So that's like our example right here. The absolute value of a is equal to the same thing that's inside if it's positive. It's going to be negative a if a is less than 0. So if the thing inside, like the -3, is negative, the absolute value of it is going to be the opposite. And last but not least, it would be 0 if a is equal to 0. So write that down, and we'll do an example with that in class next time I see you. So now we're looking at section 2, the Cartesian coordinate system. This first thing is really simple. So we're looking at an XY coordinate plane, and they want us to label a couple things. So we'll start with the x-axis, that's our horizontal axis, and the y-axis, that's our vertical axis. We'll look at the origin is the point 0, 0, and then remember we name the quadrants. The top right quadrant is quadrant 1, and then we name them in counterclockwise. So this would be quadrant 2, quadrant 3, and quadrant 4. Very simple review of the Cartesian coordinate system. Next thing, we got some distance formula. So if we have a number line, let's say here's my number line, here's A, here's B, and I want to find the distance between those two, I am going to take the absolute value of either difference, B minus A or the same, that would be A minus B. If you think about this, if this is, let's say, 12 and this is 10, well, 12 minus 10 is 2. The absolute value of 2 is 2. And if we do the reverse, 10 minus 12 is -2, but the absolute value of -2 is also 2. On a coordinate plane, so that's looking on something like this, where we have 2 points. We'll say this is x1, y1, and this is x2, y2. And if I'm looking for the distance between these two, I'm going to take the square root of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. And realistically, you could actually switch the order of x2 and x1, y2 and y1, as long as they are consistent. So if you had put x1 minus x2, that's fine, as long as you put y1 minus y2. All right, let's look at the midpoint formulas on a number line. Again, if I have A and B, and I want to find the midpoint right between them, pretty easy. I'm going to take values A and B and add them, and then divide it by 2. And on our coordinate plane, same drawing as above, right? Let's say this is x1, y1, and this is point x2, y2. If I want to find the midpoint here, the point right in the middle, I'm basically taking the midpoint formula on a number line for each x and y. So our midpoint is going to be x1 plus x2 divided by 2. That's going to be the x coordinate. And then y1 plus y2 divided by 2 for the y coordinate. Last page of notes. Standard form equation of a circle. First, I really quick want to talk to you guys about what a circle is. I know you can picture one in your head, but technically, a circle is a set of points that is equidistant from a center. So we know a circle looks like this, right? And it has a center. This from the center to the outside of the circle, we know is called a radius. We're going to call that R. And the center often is labeled as HK if it is on a coordinate plane, which is what we're going to be dealing with. So the standard equation of a circle is x minus h, quantity squared, plus y minus, k, quantity squared, is equal to r squared. All right, those are our notes and I will see you in class.